Ma'am, today I Priyanshu Kahera will be explaining about the experimental about critical solution temperature. In this experiment, we will measure the variation in miscibility with temperature and to find the effect of impurity on critical solution temperature. The system we are using is N-butanol and water system. Before diving into the experiment, we should know that what is CST. CST is a temperature at which solution undergoes phase change or at which two partially miscible liquid becomes miscible at all proportions. These are of two types, upper CST and lower CST. Upper CST is a temperature when the phase separation occurs at temperature below critical temperature, and LCST when the phase separation occurs at temperature above critical temperature. Diving straight to the experiment, our aim is to study the variation in miscibility of N-butyl alcohol in water with temperature and to find out the critical solution temperature and to investigate the effect of impurity on critical solution temperature. The material required are glass boiling tube, thermometer, stirrer, beaker, volumetric flask, pipette, hot plate. And the chemicals required are water, N-butanol, NaCl solution, naphthalene. The theory of this experiment is that when we mix two solutions, there are only three possibilities. Either they are completely miscible, partially miscible, or miscible. In the case for CST, we mainly study about partially miscible because they are miscible at high temperature. The number of homogeneous, mechanically separable and physically distinct part of system are known as phase. As an example, when we mix N-butanol with water, they form two distinct layers. Thus, we can say that they are in equilibrium with each other, and it can be said that they are conjugate solution. Mutual solubility curve. If we have two liquids A and B and we mix them, we get a mixture of composition C at any temperature. T1C, the liquid separates into two layers of different composition above T1C. The two layers are completely miscible. The point correspond to temperature T1C and composition C1 is known as miscibility point. So the procedure is 2 ml of N-butanol was taken into boiling tube. After that, 2 ml of distilled water was added to it. The solution was stirred in the boiling tube, and the boiling tube was kept on a beaker having water which was constantly heated, and the solution was stirred. The solution is stirred, and when the turbidity disappeared, the temperature is noted and the solution is kept aside for the cool down, and temperature is noted again when the turbidity reappears. So same procedure was repeated after each addition of 2 ml of distilled water up to 5 readings, and then the same procedure was repeated with impurities. So the observation we get from the experiment are these three tables which shows the percentage of N-butanol in water with impurities like naphthalene and NaCl, and these are the three respective graphs which shows the CST of water and N-butanol system with impurities. So the conclusion is, in this experimental miscibility temperature of different mixture of N-butanol and water are determined. A graph is plotted by taking percentage composition of mixture along x-axis and miscibility temperature along y-axis. Temperature corresponding to highest point on the dome-shaped curve gives the CST of the system. The presence of small amounts of impurity produces a very large change in the CST values is usually a linear function of concentration on impurities. So this is the journal which I have taken the reference material, and these are the respective textbook. Thank you.